Have you ever spent hours in frustration because of some bug in your program? You'd like to fix it, only you never took the time to check your code for errors. This is where JUnit Testing comes in. JUnit Testing means testing the smaller units of your application, like the classes and the methods. The benefits are that it saves time from diagnosing errors in the future because you test out smaller chunks of code rather than testing the entire program at once. Before we begin, it is necessary that you have an understanding of the fundamentals of Java programming. In this demonstration, we will be using JUnit testing to test a car simulation. The car receives an integer of the year of the car model and a string of the car make inside its constructor. We have set the speed as having 0 miles per hour. We have methods that get and set the year of the model, methods that get and set the make of the car. We have methods that accelerate, brake, and finally a method that returns the current speed. The first step in JUnit testing is right-clicking on the class you want to test, and then at the bottom, click Create Test Class. You'll see a green box appear behind your class. It will automatically be named the name of your class plus test. Click it. Let's first add our name. We won't be using most of the information found in this test right now, so after inputting your name, let's delete most of it. We will now create a test method for the first method in the car class. You must add @test before any test method, and then I'll type in public void test get year model. It is good practice to have test be the first part of the method name, and then we added getYearModel, as getYearModel is the first method that we want to test from the car class. In each method, we have to create an instance of the car class, because all tests must be independent of each other. For this method, we will create car1 equals new car. And then remember that our constructor accepts two parameters, the year model given and the make given. So we'll type in the integer 1965 as the year, and the make we'll type in Mustang. Compile. JUnit testing has a great function called assert equals that we will be using. We use assert equals to compare a value we expect the method to result in with a value that will actually occur. Using assert equals ensures that our method is functioning correctly. The format of assert equals is assert equals expected value, actual value, and the delta. We will get into what the delta is later, but for now let's focus on the expected value and the actual value. So we've passed 1965 as the year model in the constructor, so that is the value we are expecting to receive from the getYearModel method. Let's type in assert equals 1965, and to get the actual value, we'll call the method getYearModel in the car class by typing in car1.getYearModel. Now, if the expected value, 1965, is the same as the actual value, which we got by calling the getYearModel, the test will have succeeded. We can test the method by clicking on the car test, and then click void test getYearModel. And we see that the test was a success. Now, not only is it important to test the program to succeed when the values are the same, but it is also important to test the program to fail when the values aren't the same. One positive test, one negative test. Giving the program this dummy negative test ensures that the program is functioning correctly, because if our expected value was different than the actual value, but the test was still successful, there can be an error in the program's functionality. So I will enter 1964, even though I know this expected value is incorrect. We'll compile and let's test it. And we see that there was a failure. Anytime there is a failure in your test, this window will appear. If we click here, we can see that our expected value is 1964, but our actual value is 1965. What this failure tells us is that the program is reading all the information correctly, and when there's an incorrect expected value, a failure will appear. Let's change this back to 1965, compile, success. The next method we want to test is the getMake method. Let's first include @test and public void test getMake. We will create a new instance of the car class, so I'll add in car2 equals new car, 1965 Mustang, and then we'll do assert equals Mustang. We'll be testing that string, and then we'll call the getMake method. Let's compile. Test was a success. Now let's run a negative test to make sure that this program is functioning correctly. We'll say that the expected value is Mustang, which is obviously incorrect. Let's compile and run the program. We see that there was a failure. Our expected value was Mustang, but the actual value was Mustang. So the program is reading all the information correctly. Let's change it back. Success. The next method we will be testing is the getSpeed method. Let's create it by first adding test and public void test getSpeed. Let's create a new instance of the car class. So the speed is initially set as having 0 miles per hour. So that will be our expected value. 0. And we'll call the getSpeed method. Let's run the program. And we see that the test was a success. Let's give this method a negative test. We'll say our expected value is 1. Failure. Our expected value was 1, but the actual value was 0. The program is reading the information correctly. And this method works perfectly. Success. The next method we will be testing is the accelerate method, which is used in conjunction with the getSpeed method. We see that accelerate adds 5 miles an hour to whatever the current speed is, the current speed being 0. Let's create this method. @test public void test accelerate. Let's create a new instance of the car class. Car4 equals a new car. 1965. Now let's call the method accelerate. We can do car4 dot accelerate, compile. So now 5 miles an hour has been added to whatever the current speed is. So our expected value will be 5. We'll compare it to the actual value. And we see that the test was a success. Let's add a negative test. Change this to 4, compile, failure, expected value was 4, actual value was 5. The method works perfectly. Now I will explain to you an additional feature of the assert equals, which is called the delta. Delta is a third value you can input into the assert equals function. It allows for a margin of error to occur between the expected value and the actual value while letting the test remain a success. An example is to go into our accelerate method and to say our expected value is 4.5. The actual value is 5, which we know, and we'll say that the delta is 0.5. What this means is that any speed that is 0.5 miles an hour more or less than the actual value, which is 5, will allow the test to remain a success. Let's see if it's a success. We'll compile, and we see that the test was successful. Now, delta is used because there's always a possibility for a rounding off error, especially when using floating point numbers. The smaller the delta number is, the closer the actual value must be to the expected value. Let's see what happens when we get rid of the delta. Compile, and we see that a failure occurred. This is because there is no room for margin of error. The expected value does not equal the actual value. I'll change this back to 5. The last method we want to check is the break method. Let's create it by typing test public void test break. We'll create a new instance of the car class. We'll call the break method from the car class. And then we'll compare it. One second. Where's the error? Car 4, car 5, that gets speed. Assert equals. So we've put -5 because the break method subtracts 5 from the current speed. The current speed is 0 miles an hour. And it's not 5 miles an hour because these tests are independent. Also, I know it's not possible to have a negative speed. However, all this test method will be doing is testing that the break method actually subtracts 5 from the current speed. We are not testing what would happen or what the result would be when we accelerate and then brake. We're just testing the brake right now. So we're expecting -5. Let's test it. Test was successful. Let's give it a negative test. We'll say it's -4. And we see there was a failure. Expected value was -4. Actual value was -5. So we know this method works. Compile. Now, if we wanted to see how the brake method would work after we accelerate, we could go to the test get speed method, for example, and let's first accelerate. So we'll say car 3 accelerate. We've added 5 miles an hour. Now we've subtracted 5 miles an hour. So now the value should be, the expected value should be 0. Actual value should be 0. We see the test was successful. Let me change this back really quickly. So we have tested the methods in the car class using JUnit Testing, and we know the program works. Thank you for watching.